So when I'm teaching about kinetic energy, one thing I kind of like to do is, as an astrophysicist, go back and actually talk about astrophysical concepts. One of these things is in 1972. This was a photograph taken lake up in the Idaho area, and that right there is not an airplane contrail. That's actually a meteor, daylight, middle of the afternoon, and visible from the ground. And so what was happening was, it's got to be very bright. What was happening was something was hitting the atmosphere and skipping off the atmosphere, ionizing the air. That was the trail that you. My understanding is it actually may have dipped in twice, like a rock skipping along the surface of a lake, and it traced back in the general direction of Gulf of Mexico, maybe. And so this was 1972. So what happened was, when this thing hit the atmosphere, ionized the air, an interesting thing happened, and that was it triggered a response from our defense uh, systems. That radar picked this thing up, and radar reflects off that ionized air. Well, it reflects differently than it would off of an airplane, but it reflects off ionized air. Well, besides meteors, what also would reflect would be a missile entry trail. And so this is about a decade after the Cuban Missile Crisis, and so this was something that we're looking for as a possible strike, and all of a sudden you had an entry trail and possibly another entry trail, and they all trace back to the same direction. Looks like maybe a first strike. Okay, if this thing, they realized if this thing had come in about a half a degree steeper, it would have dived down and hit the ground. Now, when it hits the ground, it's going to stop. Well, if you got to conserve energy, so if it stops moving, you no longer have kinetic energy. So all that energy has to be released, and it gets released in the form of a gigantic explosion. And so the question is, how big of an explosion? Well, normally when you got an explosion, you rank the explosion, a really big explosion, in terms of really big explosives we're familiar with. So I would want to know, how much trinitrotoluene would it take to make an equivalent explosion like that? Well, I know the kinetic energy. So the kinetic energy is 1/2 mv squared. Analyzing the radar signature, we realize this thing is about 4.5 million kilograms, assuming it's made of normal silicate type stuff, regular rock. Okay, and the velocity was about 15 kilometers per second. Well, 15 kilometers per second is going to be 15,000 meters per second. So the kinetic energy, when you multiply all that out, 1/2 mv squared is going to be a really huge number. That comes out to be 5.06, or we can probably round this to 5.1 times 10 to the 14th joules. Okay. So, now the question is, how big is that? Well, 1,000 tons, or 1 kiloton of TNT, releases an amount of energy that is equivalent to 4.2 times 10 to the 12th joules. So we would take the 5.1 times 10 to the 14th joules, divide by 4.2 times 10 to the 12 joules per kiloton. Okay. And so what that would give you is, that this 5.1 times 10 to the 14th divided by 4.2, 10 to the 12, is about 121 kilotons. That's like a small hydrogen bomb. To put this into perspective, the atomic bomb that was dropped on Hiroshima released 5.5 times 10 to the 13th joules. Okay. So um, so that means that's about 13 kilotons. So that means that this is roughly as big as 10 atomic bombs or A bombs. Okay. Now, this was 1972. Cold War was going on. If we'd seen something coming in that looked like a missile and it detonated like a small hydrogen bomb, then we might have responded, assuming that we were under attack. Because in the 1970s, the strategy was they called it mutually assured destruction. They were afraid that incoming missiles would take out our missiles, so ours were already programmed, pre-aimed, and if bombs started raining down on us, we just fired them because we had a pretty good idea who might be attacking, and so we would fire ours and get them off the ground before more missiles came in and took them out. Now, of course, this was not a missile coming in, so what would have happened is they would have responded by seeing us launch, and they would have responded by same thing, launch all their missiles to get them off the ground before our missiles got there. Whereupon our allies would see them launching and would then launch, and then their allies would see us and our allies launching, and they would launch, and that would be pretty much World War III and the end of the world. But that didn't happen. This event actually scared them enough that they developed protocols to try to tell the difference between incoming missiles and something like a meteorite. And depressingly, turns out Earth is actually hit by an atomic bomb-sized meteorite about once or twice a decade. So this does happen from time to time, and not that many years ago, one actually landed in Russia between two cities and injured about 1,500 people. Nobody died miraculously, but it was a substantial event.